Gentlemen, it's a pleasure for me as chair of the French market regulator AMF to be here today to briefly present the regulator's approach on artificial intelligence and introduce the next session of your work. Let me start by saying that artificial intelligence, obviously, I'm not saying anything new, is rapidly reshaping our financial ecosystem, and its rise and its implications for regulation, market participants and investors are obviously one of the major subjects that we are addressing nowadays as regulators. So let me say a few words about the IMF approach to AI. First of all, it's a positive approach. I think it's worth saying it because as regulators we could have a temptation to consider that innovation creates risk and thus is a problem. That is not the way we are addressing innovation. It is indeed in the DNA of IMF to be pro-innovation and to try and foster it on the financial center. It's indeed one of our 6 strategic priorities, and we have, as a regulator, a vision of our role, which is to oversee markets as they exist today, but also to anticipate and accompany the major transformations that will define the financial system of tomorrow. Artificial intelligence, obviously, is clearly at the heart of these transformations. It is profoundly changing how financial services are designed, delivered, and supervised. And if I may, this is probably only the beginning. Our approach is structured around several pillars. First of all, our own use of artificial intelligence for regulatory purposes. We are actively developing tools to strengthen our analytical, supervisory, and risk detection capabilities. Second, the understanding of market practices. We are monitoring closely how financial institutions are adopting and using AI, and, if necessary, remind them on the applicable rules. Third aspect, the use of AI by retail investors or in the retail area. This creates, obviously, new challenges for investor protection, and as a market regulator, this is the first of our mandates, among others, to protect investors, but this one is really key. And fourth point, a shared understanding of the issues posed by AI, or opportunities, by the way, at the international level. And obviously, this is a global subject, and we are addressing it as much as possible globally among market regulators. Integrating AI and understanding its impact on financial services, markets, clients, but also potentially financial stability is not something that we consider as optional. It is essential for the future of our financial ecosystem and its stability. Let me turn now briefly to the first point, which is how we are using AI within the IMF. The use of AI is transforming financial markets, but it's also transforming supervisors. At the IMF, we are already leveraging AI to better process and analyze the ever-growing volumes of data that we are receiving. Over the past years, we have made significant investments that have enabled us to automate a number of processes and a number of data use that we have now the opportunity to do on the basis of the many reportings that some people here find cumbersome but prove very useful for us to understand and follow up and follow what is happening on markets. We are also integrating machine learning techniques into our supervisory tools. These developments are not theoretical. They have already very concrete applications. I will only mention two. First of all, it enhances our ability to detect market abuse, but also to identify what we are calling false positives in the many atypical patterns that our systems are detecting. The second point is investors' protection. We have developed, and we wish to develop even more, to be frank, automated tools that allow us to detect malicious websites. You know that frauds and online frauds, it's probably one of the major challenges facing the financial markets. We are seeing what I can only call a surge in malicious frauds, malicious and fraudulent websites. And so it is to us absolutely key that we become more and more efficient in order to fight this situation that is clearly undermining confidence in the markets. Let me just quote one figure. 16% of French citizens consider that they have been victims of online financial fraud. It's a huge figure, and it raises to 32% for the under 35 years old. So obviously, it's not only a financial subject, it's a society problem, and that's why we are looking at means to be more efficient. We, of course, also are using AI to improve our capacity to analyze regulatory documentation. And we are also looking at other opportunities offered by generative AI in terms of legal research, but also internal assistance that can support our teams in their daily work. From that point of view, we are very vigilant about confidentiality, data protection, and sovereignty of where our data are. That is probably one of the reasons we are not going as fast as we would like to in some cases, because in many situations at this stage, but I hope this will move rapidly, we are constrained by, we have legal constraints or constraints that are global for government and public authorities to refrain from putting non-public data in an environment that is not completely safe in terms of where the data are located. But I hope this will change soon, and for us it would be a great opportunity to go a few steps further. Let me now focus on how financial market participants are making use of AI. We are trying, obviously, to monitor that as closely as possible. Things are moving very rapidly. So what we did is we conducted a study, a survey, as part of a broader European initiative, which was published just last February this year. We made a survey of the French financial industry, and what we saw is a very high level of adoption. Around 90% of market participants are already using AI or are planning to do so in the very near future. This is obviously a very strong momentum around generative AI, which is opening new possibilities across a wide range of functions. More than half of the identified use cases are already in production, especially within large financial institutions. And investments in AI are expected to continue growing significantly in the coming years. At this stage, to go into a little bit more details, the majority of applications remain internal. Firms are primarily using AI to improve productivity, analyze large data sets, summarize documents, and develop internal assistance. Pretty close, by the way, to what we are doing ourselves. Client-facing applications, such as AI-driven investment advice or personalized financial services, are still relatively limited, but they are developing very rapidly. This is an area that we are monitoring closely, given its direct implications for investors. Another key finding is the strong reliance on external technology providers, and I could add also, in many cases, the concentration of these providers, which is clearly a subject that needs to be addressed and identified in the financial sector, but also among regulators, since most of those providers are located outside of Europe, which raises questions around technological dependency, concentration risk, and control over critical systems. The benefits of AI are widely recognized by market participants, but they have also, and I'm talking about what the firms have identified, several major risks. This will be discussed, I think, this afternoon, but let me just mention a few of those risks. Issues related to governance, data protection, model transparency, and the need to maintain meaningful human oversight on what AI is producing. Encouragingly, most institutions have already started or put in place a specific AI governance framework, which is absolutely key to good use of AI. And to wrap things up, let me also mention that use cases can vary significantly across different types of actors, financial players. Asset managers tend to develop AI on data analysis and compliance. Investment firms are more active in automation and client interaction. Market infrastructures use AI also for transaction monitoring. Listed companies, law firms, and auditors rely on AI for document analysis and reporting. This diversity of use cases reflects both the versatility of AI and the need for close monitoring of these stakeholders, sector by sector. Let me now address briefly the regulatory perspective on the use of AI in investment services. A recent ESMA is our European institution, Autorité européenne des marchés financiers in French, and it's the financial regulator in Europe. A recent ESMA's regulatory communications have made one point very clear. The use of AI does not change the fundamental responsibilities of financial firms. This is obviously key. It's not because AI is entering into the system that it changes the situation where financial firms are responsible. Even when decisions are supported or generated by automated systems, firms remain fully accountable of the results and of their actions. Core obligations, such as acting in the best interest of the client, ensuring proper governance, and complying with conduct and business rules, continue to apply. This is why a robust governance is essential. As noted also in our study, outsourcing is another critical aspect. When firms rely on third-party providers, they must ensure that they retain control over their systems and are able to manage the associated risks. This is at least our expectations, and it's important that they are well taken into account by financial entities. Transparency towards clients is also key, particularly when AI is used in the provision of investment services or in interactions with investors. The retail topic, as I mentioned, is clearly a very important one and is another trend that we are following very closely. Artificial intelligence is not only transforming institutions, it is also rapidly changing investor behavior. From that point of view, we have also conducted a study on the subject, and it shows that I'm trying to think the analogy is not completely wrong. Retail investors are more or less using AI now in the financial sector as they do when they have an appointment with their physician, meaning that they will first look at information ask the artificial intelligence to give them information on their investment, and then they will go and see the doctor and get a proper prescription. This is more or less what we are seeing. What is interesting is that already at this stage, our survey showed that 11% of retail investors use AI as their first means of information. It's not the only one. That's why I was mentioning it's slightly close to what is happening when you have an appointment with your doctor, but still, and this is, by the way, reassuring. What we saw is that 11% of investors are first looking at AI, but a vast majority of them are then asking for more advice. These tools are primarily used by financial retail investors to better understand financial products, analyze market trends, and identify potential investment opportunities. In many ways, from that point of view, AI has the potential to empower investors by giving them easier access to information and analytical capabilities that were previously reserved to professionals. However, this evolution also raises important investor protection challenges. First, AI tools available to the general public are not regulated, contrary to the financial sector, which is a regulated sector. So we have to make sure that AI does not go beyond what is allowed and would lead them to become somehow financial advisors, because financial advice is obviously very regulated, and we don't want unregulated financial advice to potentially mislead the general public and create investor protection issues. There is also the issue of data protection, which is key. And for all these reasons, it is essential to promote a cautious and informed use of AI and raise investors, and especially retail investors, awareness of what can happen when AI is used when you are using AI as an investor. ESMA has published a few months ago a statement, especially for retail investors, to just give them a few hints of what they should be looking at if they are faced with AI, and if either they are using AI, I would say, on their own, or if the financial services providers are using AI. Let me conclude with a broader international perspective. As I mentioned, AI is a global phenomenon, and its implications for financial markets are being examined at the international level. We started to look at it at IOSCO, and inside of IOSCO, we started to look at it from a financial stability point of view. A few years ago, maybe 2 years ago, if I'm not mistaken, we conducted a deep dive within the Financial Stability Engagement Group, which I'm co-chairing with the chair of the CEO of the FCA, Nikhil Rathi. And we started to have what we are calling deep dives. That's what we are doing basically when we are faced with a new subject, and we know it's developing, and we first want to have a broad view from market participants, other regulators, and also several institutions when we want to have a better view of it. We did the same, by the way, at the French IMF. We have now a new type of meetings called Atelier de l'Innovation, which is one way for us, and it's organized by this gentleman, Charles Moussy, whom you will maybe have the opportunity to interfere with later in the afternoon. We are trying, first of all, to understand what's going on and also monitor it, because one thing key with AI is that obviously it's changing very rapidly. On top of financial stability, monitoring the potential impacts on financial stability, IOSCO is also looking at mapping of current and emerging use cases, identifying key risks for investor protection. I mentioned it at the European level, but obviously it's not a European-only issue. Market integrity, financial stability, and also to have exchanges and analysis of regulatory responses worldwide. This is a common observation, something that all regulators are sharing. AI is increasingly used across a wide range of financial functions, and I mentioned what we have seen in France. At the same time, several types of risks have been identified. They include model and data risks, but also potential systemic risks, concentration, and technological dependency. By the way, we had an international, organized and held with a French think tank called AEFR, whose chair is in the room, and I'm saying hello to Pervenche Berès. We organized a big conference last year in Paris, gathering both international regulators and market practitioners with a view to understanding and identifying the technological trends that could affect the financial sector and its risks. We had a big session on quantum computing, something you might be also looking at, but we also dedicated a session to artificial intelligence. I think we all learned a lot. In most jurisdictions, what we are seeing is that a number of good practices are emerging, which is a good thing. Existing regulatory frameworks are also being applied to AI use. And obviously, this is both something that we are looking at. We are not too preoccupied, to say things bluntly, but we are also monitoring closely, as I mentioned several times, because things are evolving very rapidly, and I'm pretty sure, by the way, that the discussion on risks today will lead us to have more insomnia tonight, but that is something that regulators are used to because we are paid to identify risks and see them emerging as early as possible. Our main role, though, is to strike the right balance. As I said, we are not there to curb innovation. It's very important to say, because innovation can also bring a lot of good things. It can foster competition. It can, even in the regulatory area, improve the situations. One of the uses of AI, I hope I did not forget to mention it, is to improve compliance. And there are a lot of tools on that point of view. But obviously, we have to strike this right balance between supporting innovation, making sure that investors, and especially retail investors, are aware of the implications of AI expanding use, and also that financial actors are in full command of what they are developing. It represents, all in all, a major opportunity. I do want to underline this, but also challenges for financial markets and obviously for the regulator. So I will stop with that. And I think it's my duty now, after this certainly too long introduction, to first thank you for your attention, but also introduce the guest speaker of this session, Professor Markus Leippold, who will share his insights on AI and the integrity of knowledge. Well, that should be pretty interesting. Just a few words, Professor, while you are joining me, because I will let you have this place in 20 seconds. You are a professor of financial engineering at the University of Zurich. You have previously held a faculty position at Imperial College London, and you have an extensive experience working with both the Swiss banking industry and leading technology firms such as Google. So obviously you are best placed to describe the evolutions of AI in the banking sector and its risk. You are also serving on the advisory board of Innovest, and you are a co-founder of Frigg, a platform connecting investors with sustainable projects. By the way, I could also have mentioned that helping supervisor reviewing sustainable finance documentation is also one of the major use cases for regulators of AI. And your research focuses on climate finance, which I can only commend. You know that we are strong believers of green finance here in France and at the French IMF. You are focusing on climate finance, natural language processing, asset pricing, and risk management. That's a big program, so the floor is yours to describe it. Thank you very much.
Well, thank you very much for the kind invitation. Let's see whether this works. My talk will be about AI and the integrity of knowledge, and this sounds like a very esoteric title, and indeed, you know, the topic that I will discuss is based on 4 papers. 2 papers are already on SSRN, but very unpolished, and 2 other papers are still not even available on the web. Maybe some for transparency. I'm a professor now in financial mathematics since almost 25 years, so that's my 25th year. And back in 2017, I fell in love with transformers. And I thought, well, I'm going to switch to natural language processing. This is how we called AI in the early days, because, you know, it's kind of a niche field and nobody is really interested in that. So I went to deep dive into natural language processing. I joined Google back in 2019, first as a full-time employee for around 1 year, and then I switched to Google DeepMind, and still today I work 20% for Google DeepMind, so everything that I say today is not related to Google DeepMind, so I always have to say this because they're very picky on that. You know, when we talk about AI and the problems of AI, we focus on risks like job displacement, like inherent biases, and I think that these are not the most problematic risks of AI in general, because AI can affect something which is very important for us as a society. And you know, being so long a professor and retirement is already visible at the horizon, I can think about bigger problems. And one thing I really like to talk about and think about is the impact of AI on our knowledge base. And our knowledge base is very important, not just for finance and making, you know, a little bit of money out of the financial market and be better than Goldman Sachs or some other investment bank, but, you know, for us as a society, it's very important to think about how AI will actually change the way we think about the world. And therefore, I think I wanted to look at 4 kind of topics or traps that we can actually fall in. They are not necessarily directly related to finance because, as I said, I abandoned the finance field a little bit over the last couple of years, went more degenerated into computer science. So the first trap is epistemic trap. I'm going to talk about that. The second one is homogenization trap, which is then important for finance and also for regulation on, you know, how you want to regulate the use of these AI agents across the board. And then the infrastructure trap, which is very important also from a regulatory perspective, because we generate a lot of dependency on big tech. We all use more or less the same models because these are the cool, great, very powerful models, and then there are some smaller models, but they're not as good. And then the information trap, which brings me back then to, you know, the knowledge base that we use in order to make decisions in our daily life, and the potential of misinformation, strategic misinformation, that can happen or becomes very cheap using AI, and verification is very, very expensive compared to misinformation. And this asymmetry leads actually to some very bad impacts on us doing decisions as economic individuals. So what I mean by the epistemic trap? Well, nowadays, we are researchers at university. We have a task to do, which is produce papers, and then we can advance our academic career, right? So this is what we are paid to do. And now we have this technology, AI, which helps us to become more and more productive. Might not be that big of a problem in finance, but definitely in computer science, for instance, or in biology or in mathematics, it's important to generate a lot of papers, and some of these papers get the lucky draw and will be published in the top journals, so you're advancing your private career, but you generate potentially a lot of contaminated research that is not as good as if only me as a human would have done this research. And this contaminated research will be then picked up, for instance, by literature reviews, or even more problematic when you think about climate, picked up by research synthesis, like the IPCC and others. They will do a synthesis. For the next IPCC report, the authors for the IPCC reports, they will have to digest 1 million articles. And you cannot do that anymore without AI. And AI needs to be on top of the task, right? But is it really as good? Because if it's not as good, we generate false consensus of research, which will be then fed into the AI again, because as AI labs try to extract high quality research to train their models, to make their models even better, we have to use this, right? It's not kind of a divine, invisible force that makes AI better than humans at some point. It's the humans that train AI. And this contamination can have a very bad impact on our epistemic foundation. And I did 2 natural experiments. The first one is ICLR. ICLR is one of the top AI conferences. It's one of the top 3 AI conferences. I was looking at around 20,000 submissions. So this is the level of submissions that we have these days in these computer science conferences. So 20,000 papers have been submitted. There have been 75,000 reviews, a little bit more, that had to be done on these submissions. And then, ICLR last year, in 2025, this is for the ICLR 2026, so the submissions have been in 2025. They used Pangram, which is supposed to be the best AI detection tool these days, to screen for AI content. So I had all the papers categorized into the AI content, so how much of the article was generated by or connected to AI, generative AI, and also for the reviews. I had an assignment of whether the review is AI generated or not, which is of course great, because then I can look at, when you have a model in mind where you have at some point humans and on the other side AI, if humans and AI would collaborate in an efficient way, Markowitz frontier, then you would have this curvature, and you might find a sweet spot for optimal human-AI collaboration, right? And then it depends, the curvature depends on whether the AI is actually better than humans or worse than humans. If it's worse than humans and there is no AI collaboration but only substitution, then it's kind of a straight line, right? And what I found using the data, it's a straight line and it's pointing downwards. So this means that the more people are using AI, whether it's 10%, 20%, or 50%, on average, the quality of the papers, the soundness of the papers, or the rating of the papers will decrease.
And it's human rating?
It's human rating. You can condition on the human rating. There are some papers that then I used for within paper comparison that had both ratings. And this brings me to the next finding, which is if you use AI ratings, we train our AI to be polite, right? So we want to please you. And therefore, you have this general bias also when you use AI for reviewing papers. So you get a better review if the review is not done by a human. So this is exactly what happened with the AI reviews. The AI reviews were more lenient, so basically more papers got accepted because the reviewers were overwhelmed with all the review. I cannot review the papers that I'm invited to. So you're overwhelmed as a reviewer, so you use AI to review. And the outcome will be more lenient. So you get a better rating if you have an AI-generated review. This happens, so first the level changes, and also the variance of the reviews changes. You have this typical Bayesian shrinkage kind of feature that you generate. The variance of your distribution, if you use AI, is compressed. And this is a typical feature in AI and in computer science. We know about this problem. You have this mode compression of AI tools that is actually happening. And the third finding that I was looking at with the other data set from Retraction Watch, which is a data set that looks at how long papers stay in the epistemic universe before they get retracted because they have some errors. And it actually turns out AI-generated papers are, if they have a problem, are harder to detect than problems that are generated by just humans. So they stay longer in Google Scholar, if you want. So other people will cite this research, but this research is actually flawed. And this is a problem for science as such, right? Caused by us academics who need to produce papers at all costs to advance our career. Well, I'm out of this race, but especially the younger ones, right? But now think about it. If this happens for science, what does this mean actually for finance? We're all using our AI, and this AI suffers from a quality issue, and it suffers from a compression issue, that the variance is compressed. And this has an impact on finance, and this is my second trap. I call it the homogenization trap, and the paper, still finding a nice title for it, is Democratization versus Homogenization. And I'll try to understand a little bit what happens when people are making decisions based on AI tools, or you have AI, no, people are not making decisions anymore. The AI agent makes the decision for you. Two forces. So construct a theoretical model, you do all this blah, 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 the stochastic differential equation, partial differential equation, you solve some partial equilibrium, and two things can happen. First, democratization, meaning that, these days my students sitting in Zurich, can do what Goldman Sachs has done 10 years ago. Analyze 10,000s of analyst reports within one afternoon. So everybody can use large language models, and that might cause some kind of democratization. You don't need to have an analyst. You don't need to run to Goldman Sachs for getting advice, pay first a lot of money. You can do it on your kitchen table. So there's democratization, but there's also homogenization, which refers to the problem that I was referring to when I looked at the science part. What I find in the data, well, there's some modeling device that I implemented. So a large language model receives a signal, and the signal is usually, the signal can have common errors for all language models, but they can also have heterogeneous input, right? Not everybody is putting the same stuff into the same model. It's like when we do our econometric models. Somebody uses a gauge one tool, somebody else uses another gauge. So this changes a little bit. But you have a common error. And in computer science, there is some research that analyzed, for instance, 350 different large language models with different kind of reasoning capabilities. And they found that the more skillful large language models get, the more correlated the errors become that they make, right? And this is kind of concerning because, you know, in the old days we used ChatGPT to write birthday cards. It's kind of not a lot of stakes are involved, except that maybe your grandmother gets a little bit angry because it looks like AI generated, but that's it, right? But then the models get better and better, and we use it maybe to control an atomic reactor. And then if you make an error, that's going to be very problematic. Well, you don't have to think about the atomic reactor, but think about your client's portfolio. And we have regulators here, so you have to be super careful, right? So I constructed this model, and what I found in one slide, analyzing the different regulatory filings, expected regulatory filings, unexpected regulatory filings, is that there is some indication for democratization in the sense that more and more analysts are putting out revisions, so the quantity increases, and also the speed increases for analysts. So if you have an unexpected 8K filing, for instance, the reaction of analysts since the arrival of ChatGPT has increased a lot, statistically significantly increased a lot. So revisions are out much faster, which is clear because people are using these models to analyze the text. They're not reading it anymore, which makes perfect sense, right? What I also found is some preliminary evidence that the quality of the revisions decreases, actually. You see a lot of additional overshooting in the price reactions due to the analyst revisions with subsequent correction again. And if I link that to, grab a little bit of this, of the magic box of natural language processing, you take a couple of different key measures to measure the complexity of the text. And if you link this complexity of the text, you see that exactly those companies who have the most complex kind of language in their reports are actually those that have the highest overshoot, which means that you have this homogenization of LLMs, and then if you look more carefully at the text, you see that actually this price reaction is unjustified, and therefore you have some correction there. Now, the infrastructure trap. Infrastructure trap is very easily explained. Basically, we have only a couple of providers, OpenAI, Anthropic, Google DeepMind. These are the big names. And this is the AI intelligence that you put on top of your data. Of course, you can use DeepSeek or some other tools, but they're not as good, I would say. But you might not want to have some Chinese dependency anyways. So, but US dependency, well, okay, take Mistral, right? But still, it cannot really compete. Then you have a couple of cloud platforms. Well, basically three, AWS, Azure, and Google Cloud. You have AI Accelerator, NVIDIA GPUs, Google TPUs. NVIDIA has about 80%. And then you have semiconductor fabrication, TSMC in Taiwan, and extreme ultraviolet lithography in the Netherlands with ASML. So you have these dependencies. And you know, you put your, it's like going to the Olympics with steroids, right? So you put your company on steroids with all this AI stack in order to compete. It's definitely true for finance, it's true for biomedical research, for instance, and you create this dependency, but you often forget about this supply chain dependency that you generate. I analyzed a couple of political events in the US. I identified 19 different events. They were sometimes tightening. For instance, in January 15, 2025, the Joe Biden at the top of his cognitive possibilities was signing the AI diffusion bill, which was categorizing countries into friendly countries, kind of not so friendly countries, and Iran, Russia, and others. And the friendly countries were Germany, France, and some others, and they get access to US AI infrastructure without any problems. Then there were the not so friendly country, 121 countries, and I'm Swiss. We are evil because we export chocolate and cheese. We were in this category. But this has impact, right? This has a big impact on you as a company if you are in the wrong bucket. These were a couple of incidents, and I'm going to skip this here. What I built is a news index. So we had, yesterday morning, we had a keynote on building news index. So I was creating a news index, which I christened ADI, Algorithmic Dependency Index. So I was looking for, I used keywords. I feel ashamed. I used keywords-based approach, and I can tell you why, but I tried transformers as well, but they don't work as well for the analysis of the 10K filings as keywords, especially for this case. I used the Financial Times, so I have a collaboration with the Financial Times. They gave the data on their news. Here you see the evolution of the news index. I used the same thing for the 10K filings, so I was analyzing the algorithmic dependency of the companies, analyzing the 10K filings. And it actually turns out that you have, for all these events, you had a very negative and significantly negative impact on firms that have a high ADI, a high algorithmic dependency index. It's kind of not so surprising, but you see it very clearly in the data. Then I used also the companies that have options data traded as well, or options traded, and there the effect is even bigger. Why options? Because I wanted to look also at the changes in the implied volatility. Because actually it turns out it's not, the political events are not so much about the direction. Well, if it's a restriction, it's always negative. But if it's a loosening, it also goes sometimes negative. And why? When Biden did his AI diffusion bill, Trump was deleting this AI diffusion bill and replacing it with something else, basically saying, well, we don't use this AI diffusion bill, we decide case by case. It's a loosening, but it increases, of course, the uncertainty dramatically, right? It's like if you don't have speed limits in the streets, you can do whatever you want, and the policeman would say that, okay, no, I don't like you. You have been driving too fast, right? So how fast would you drive? So this is a lot of uncertainty, and indeed this event was actually a negative event for the high ADI firms. It also increased a lot their implied volatility. And if you try to use news data to measure the buildup of the algorithmic dependency index, you actually get an even clearer result. So I think I have to hurry a little bit, right? How much time do I have left?
4 minutes.
4 minutes. Information, 4 minutes. That's the most important one, actually. 4 minutes for the most important one. The information trap. What is this? Let me explain it with this one here. So, when we make decisions about buying an electric vehicle or some pharmaceutical products, longevity pills, whatever, we face a lot of uncertainty about the quality of the product. Or, in the early days, smoking. We saw these marketing ads of doctors smoking, recommending Camel because they're good for your lungs. So we are very uncertain, and misinformation about the efficiency of renewable energy, about pharmaceutical products, the quality becomes, can be attacked by misinformation, and misinformation becomes practically at zero cost with the arrival of AI. I can produce papers that look like academic papers, but are potentially saying that, well, CO2 is good for the plants, it's not made by humans, and all this climate thing is anyway a hoax. And that's very dangerous. And what we did is kind of a general equilibrium model where we have this problem where, as a consumer, you have to decide, you have an information environment where the signal can be distorted by a misinformation producer, and if this is happening for a longer period, the trust in the institution can also erode. So therefore, you will not change your habits anymore, and this is what Exxon does, for instance, these days, with trying to abandon the GHG protocol, saying that, well, Scope 3 is actually a fraud, and are suing the state of California. And we analyzed this for renewable energy because from an economic viewpoint, renewable energy has become so cheap, decrease of almost 90% of solar over the last 12 years, 70% in wind power. Fossil fuels are still making up 80% or more of global energy usage. And you can argue that, well, there is sticky, the cost of switching from one energy to the other, but it cannot explain this discrepancy. And we try to explain it with actually greenwashing. You can call it greenwashing. And the reason why I did that was I was really puzzled by a work that we did, just an empirical work. And I don't trust pure empirical work. I want to have a model. And the empirical work was about corporate climate lobbying. And there we found that if you do anti-climate lobbying, the shareholders will actually profit a lot. So it's beneficial for the company to do anti-climate lobbying. And for pro-climate lobbying, it doesn't work. We saw this big discrepancy, very robust statistically, and I wanted to build this model, and within this model I can actually explain that because of this asymmetry between generating misinformation and the cost of verification. And this brings me to the end, well, just about the size of the cost. In our paper, we analyzed the amount of, how the energy mix should look like if there were no manipulation. And we did a kind of a calibration exercise. And if you link that to a reasonable social cost of carbon, you would get a number like 1.5% of GDP of the cost of greenwashing. And that should be a level as an indication for trying to bill the companies that do obvious greenwashing. Because the fines that regulators give to these companies, they're small and they can be digested very easily. So this brings me back to the beginning or to the end of my talk. We have these 4 problems. They're related to our knowledge integrity, and we have to be super careful on how AI will influence the way we make decisions, right? In the early days, we were saying that, wow, if you don't know, just Google it. Sam Altman was not clever enough to come up with a better name for ChatGPT, because I cannot say, I'm going to ChatGPT. It's like breaking your tongue. But Google was kind of the first company that made a verb out of its name. And the younger generation is not Googling anymore. It's just looking at some large language model and takes that at face value. And this is a real danger for us, for financial markets, but also much more general for us as a society. So thank you very much.
Thanks, Markus, for this talk. Very interesting. Is there some question? Yes, I will take 2 or 3 questions.
Thank you very much for this fantastic talk. On the part on infrastructure, so you talked about like concentration from different layers. I think there's another aspect, it's about the data, so data input. Because actually you briefly mentioned, like Google, DeepMind or others versus like DeepSeek. So potentially we can also see a demarcation between like a Chinese wall, literally, right, between like data circulating in Europe and the States versus things which are data which are contained within the Chinese wall. So how would you look at, what's your view about that? So when data input is biased or it's partial, how to train AI and what's the implications actually for AI-driven results looking forward? Thank you.
Yeah, that's a very good question. I mean, we have large language models only because we invented the World Wide Web. This is where the data is coming from. And there, sometimes I see a lot of, and you're completely right, that could be another layer on, where these models are drawing information from. And, this Elsevier's and Springer's of this world, they are very keen on protecting their data behind the paywall. So even for the company I'm sometimes working for, it's hard to get the data, which would be actually quite interesting to work with, and therefore you have always this kind of limitation of the LLMs. And data as such is very important, but it's not that there's not enough data, the problem is that there's too many data and you don't want to contaminate your large language model with wrong data. I can give you one example. For instance, Naomi Oreskes has a very nice article where she was pointing at some research from the pharma industry about some fertilizer. They wrote a paper, well, professors wrote a paper paid by this company that showed that this fertilizer does not cause cancer. It was published in a respected journal. They were then complaining about the way this result was generated and about this independency. And the editor said, yeah, but it's okay. So if you go on Wikipedia, you would actually have a reference on this article that would say, well, it's not a problem, this fertilizer. So it was taken over by Wikipedia, and eventually, this is then fed into a large language model, and then we would think, oh, it's not a problem. And a similar thing happened with the Grok 3 kind of paper on climate change, which was supposed to be peer-reviewed, or was peer-reviewed, except that one of the authors got 1 million from Exxon to write this stuff, and this will then feed into the large language models again. So it's very, very tricky. Data is very important. Think about where the data is coming from.
Thank you for your presentation. We are told that AI is the promised land. Is the AI dream becoming an AI nightmare? I have a broader philosophical question for you, that we lose touch with reality. The reality become an unreal world with a high concentration of synthetic data and AI talking with themselves. Is that threat real to you? A threat that that we lose touch with reality through a high concentration of synthetic data?
It's a very good question, and you know, philosophical question is very dangerous for me because I could talk a lot about it, and my train is running probably on time, like the French have improved, right? But you know, it's a very good question. There is a lot of research that shows that, you know, the cognitive tasks are given to the AI, and as a humans, you start to detach. If you don't think carefully about this collaboration parameter, and this is exactly where currently my heart is located for doing research, is on improving the human AI collaboration, on how we can build in this friction that as a human, we keep on engaging cognitively and try to improve things and also work together as a group of humans together with AI, where AI takes certain roles in this whole social group process. But it's a very good question, and there's a lot of, you know, in Nature and Science, you find a lot of articles on that.
Okay, it was the last question because we are short in time, so I let the floor to the roundtable.
And I have an email, so you can email me when you have additional questions. And you find me, Google me.
So let's start the roundtable. So to see what are the different traps in financial bank, in bank. So first we will first do a roundtable. So I'm Pascal Oswald. I'm head of market and counterparty risk modeling at Natixis.
So Jeremy Poirot, I'm heading the counterparty and transversal model validation. The reason I'm here is this transversal model means includes also AI, so model risk for AI basically.
And I'm Laetitia Fournier, and I'm head of data and innovation for Natixis CIB, so working and developing a lot of AI use cases.
My name is Julien Perez. I'm the head of research of BPI France, and I'm a professor at EPITA. My research is mainly related to alignment of generative models and their use in finance.
So let's start with the first question. So we see that we have 4 different traps, and the first one traps is how we may manage today the model risk in the model in the decision making. So do you have some defense on your side today to manage this uncertainty from the model? So.
Yes, indeed. Thank you again for your speaker on highlighting all these traps. And definitively today, I used to say generative model is a good news, and large language model is a true opportunity. But as any opportunity comes risk. Sorry for this kind of obvious point, but I need to start by that. And with respect to uncertainty over this probabilistic model, because we should never forget that those large language models are basically probabilistic models. You have a bunch of capabilities to, let's say, in order to mitigate, model those risks. For example, maybe we'll have the chance to discuss that a bit later, but some of the things that we are particularly interested in BPI France is how to help automatizing financing and investment actions and capabilities. And for example, some of the things that we are working a lot those days is uses things like conformal prediction and how we can properly model, compute uncertainty over those decision of models.
Maybe I think at Natixis what we try to do to manage uncertainty for sure is to put the human in the loop. So I think Markus talked about it, to to use AI, but also to have human in the loop. This is quite critical because the idea behind is, of course, that this is only the human that can interpret its meaning and the consequence given the business-specific context. But maybe this approach is not really scalable because we cannot really check every single output, so we need to focus on the important process where the cost of being wrong is very important, and that's where we focus at Natixis.
Yeah, so it's working, yeah? It's pretty interesting because on our side, so we're trying to deal with model risk for AI, and we're basically trying to bridge these two worlds where on the Laetitia's side is very pragmatic. They have to pick one model and then probably the most efficient, not to cost control and so on. And the question is how can we control this risk? And we try to first, we have a model risk framework which we apply for all models because AI models first are models, so our process does fit for these models. And obviously there are some more questions for AI, and that's where we're trying to look at literature, do something much more in the background on large language model more than on the each use cases. It's same approach as AMF, basically. We try not to stop the innovation. So every use case has to be validated and checked quite quickly, which means there is kind of state-of-the-art work on deeper like questions, probably things like conformal prediction and so on. That's a combination of this scientific and pragmatic work. That's what we have on our side, on the model risk side.
Okay, so in finance we try to monitor a lot of risks, but there is one risk, the systemic risk that we want to monitor. Do you think that AI model are able to catch this risk or they filter this kind of risk because they are calibrate of data sets that finally give a certain view of the reality? So do you think that AI model are able to capture this systematic risk today in financial world?
Well, maybe the first thing is it's much more than just model risk. Well, talking on my expertise, it's much more than model risk. For AI is really the collaboration between technology. We talk about AI systems much more than AI models. So it's a collective work, and I think again, we're trying to monitor what we call the ongoing performance over the years and so on. So I think it's not enough, but that's one way of, I would say one way of doing at least.
I think this very notion of empirical risk comes with statistical machine learning, and even before the very use of what we call now generative models, we had this problem and this what we tend to call IID distribution, independent and identically distributed distribution, basically means that if you want to have a model that will reasonably behave with respect to your expectation, you have to have a reasonable representation of the data of the situation the model will be put on. Obviously, in practice, is almost never the case. And so comes beyond this capability of modelizing the internal risk of the model is how many guardrail you will put beyond the model itself. And thank you so much, Mrs. Fournier, to remember the fact that we have obviously definitively human in the loop, and it's not only about data, it's about all this knowledge that we incorporate into our process to, as much as possible, making sure that we do not end up in decisions that are obviously wrong and problematic, And definitely, I think you see these what we used to call variance, bias, compromise on the data we use to create the model and the knowledge we leverage once the model is deployed to try to use them as guardrails.
Maybe one challenge is that the commercial AI model, I mean, if I take ChatGPT also, provide some final prediction, but we don't have really all the distribution and the confidence scores that we can have. So it's kind of difficult also for the user really to trust. And so, as you said, I mean, that's why we are putting guardrails and human in the loop, because it's no more like validating the models that we need, but having confidence in the process to make sure that the output is correct. Because we know that those models can hallucinate, and they can, worse, provide some plausible but wrong results, and that's a problem for us in the use cases.
Okay, thanks. And today in finance, we have a lot of regulation about the modeling and the ongoing models, especially for pricing models, EMA models, EMM models, and so on. What is the status today about this regulation about the AI models? Is there something in place? Are there some projects and so on? Are there some discussion?
Yeah, I think there are lots of discussions, and it's really work in progress where we learn from each other. And I guess 2 weeks ago there was still discussion on what should we consider as AI systems, AI models with linear regression and so on. So I believe it's more, for the time being, more like collaborative work, more than just like control that we see on other models. And I think it's the right way of doing, to be honest. Just as we discussed before, it's not just model risk, and AI has lots of aspects, and that also means we have different regulators from different countries having different views, and also for the first time, like even in France, we have different like CNIL and on data side and AMF and so on. All this is pretty new for us as well. So that's status today.
Yeah, and I should say that the EU regulation today primarily targets the high-risk use. So for us, it has not so much impact, but yes, for sure, we are brainstorming internally because we see that we need to validate all those processes. And so that's why start from the beginning of the idea of the use cases, we are trying to put in place a process where we are reviewing with MRM, security, DPO to make sure that the use case is good by design, I should say, at least validating everything before putting in place. And that makes sure for us that we have a robust tool and also compliance later with the regulation. And secondly, it's also very important also for us, this process, because we want our IT team to use the tools that we have internally and validated by our security instead of all the unmanaged external solutions that we can find over the web. So this is also the guardrails that we put in place.
This question of managing the risk and managing conformity is, let's say, I would say, a deployment problem, definitively, but also a research problem on its own. Something that we are particularly interested in those days is what we call law as code, which is the capability to see how much all this regulation can be formalized in a way that we can accelerate the proper acceptation of our project. To give you a very concrete example, the validation process that we have with respect to AI tools that we want to put even for strictly internal use without any client-facing application, we have a process where we can basically validate around 60 projects a year. 60 projects a year. We have a pipeline of several hundreds of projects a year. So how do we do that? So I'm not saying that we will automatize the compliance process, of course, but what I'm trying to say here, and it's always the point in research, is that on one hand, we want to improve the process as it is, but we would like also to question the process. Definitively, the requirements are always the same. They are not here to discuss. But how we validate them in a more safe and fast pace is an open question for us. And again, all these regulations are extremely clear and extremely well formed. So in a sense, it's also an opportunity to see how we can leverage. Certainly, it's an unexpected answer that I'm giving right now. But how we can leverage all these automated process of decision to help our conformity team, for example, to better process the demand that we have with respect to prototype, proof of concept, and then at the end, hopefully, a product for our clients.
Okay, thanks. I don't know if there are some questions in the room. Yes.
Thank you very much for the presentation. I have a question regarding AI and jobs, because, and I'm specifically mentioning the Jevon paradox. Namely, do you think AI is going to reduce the number of jobs for young generation because it's increasing productivity and therefore you need less people? Or in contrast, as what was mentioned by the Jevon paradox, there would be rather a first phase where there would be a reduction of job, but then the second phase where, in contrast, because it's increasing the productivity and therefore you need even more usage of AI, then there would be even more jobs, like what happened for coal.
I can answer very locally for the team. Is it does increase productivity, meaning it does increase the quality. So we spend less time doing low-value tasks and much more time thinking about model risk, actually, our core value added. But I'm not sure if we can extrapolate.
For sure, it will change how the bank will hire interns, because today, for sure, we have interns that copy and pasting information on a website or document. So definitely, we will provide them tomorrow a draft of the presentation. And the work that we are doing today with our human resources is to understand how we will use those interns to make something different. And this is, I mean, today it's a brainstorm for sure, but definitely they will no more copy and paste those type of document. But how the problem is how the manager will have time now and spend time with the intern to provide them all the context and all the information and all their expertise that they previously had in the document or find by themselves. And now, so that will be, I think, that will need more involvement from the manager or the people or the tutor of those interns. So that's, I think, how it will change.
Thank you. Very interesting discussion. I have a question that was touched by Markus just before. There is an emphasis in producing information, right? It's very cheap to produce information, and it's super costly to verify, right? And you raised that point, Julien, as well, that you cannot cope with all the projects that are launched at the company level. So do you have ideas on how to solve that issue? Because, I mean, I see some companies using LLM as a judge and doing this automatic verification that you said you don't want to do, you want human in the loop. But how do you see that process of verifying going forward? So how can we make it efficient? So for me, it's a big issue for organizations.
What I really appreciate in your question, but also in the former presentation, is that the term that was used is information and not knowledge. So what I'm trying to say is that exactly we have a proliferation of information. And now me working in deep learning for over the last 20 years, our former presenter was speaking about the way he was fascinated by transformers. Is one of the work I have done around 2015, 2016 is what we call attention models that end up being these things that we call now transformers. What I'm trying to say is like we have this explosion, but now the big question that we ask ourselves is how we will produce knowledge beyond information. And with respect to this behavior of using language model to profuse information, to me it's about a kind of ethics, what I call a kind of ethics. See that on one hand, how we can now evolve in our practices of using language model, not in a way to produce noise, but produce information. Because the other way around, as you just explained, as people will use LLMs to produce things, people will use LLMs to filter these things. And so we will end up in a situation where you send me an email with an LLM, and I will summarize your email with an LLM. Doesn't make any sense. So it's just about, I think, it's first of all about behavior and ethics. And then, obviously, because we will have this profusion of multiplication of information, on one hand, at least, I hope for a time, we will have to use LLM to filter them. But I think the very answer is about more practices, because something I always remember when I use those models, because I have trained those models for years, I used to use hundreds of GPU in parallel for days. So I know deeply how much it costs from an energy perspective. So then it's about, sorry to say it again, it's about behavior, it's about ethics, it's about incorporating this new object into our daily practices and making it in a way that is basically sustainable. But in the meantime, I think you're right, Marie, we will have to filter out what has been expanded so far with models. At least that's my point.
Yeah, maybe just one word is the good news is that we are aware of that, like as we've seen today, and we can refrain ourselves from using only AI content. Practically, we try to do that on some use cases. We say, okay, you have to take 50% of credit analyst, human credit analyst, I mean, as input. So it's just we just have to try to mitigate that in practice because we are aware of this trap. So, well, more and more aware of this trap. So just try to find mitigation for that collectively. That's what
Okay. Thanks, Jeremy. Thanks, Laetitia. Thanks, Julien. Thanks, Marie, for the invitation. And thanks, Natixis Foundation, for the support of the session. Thanks. Bye.